here is another example. This is for class 16 of ES110. This comes from Hibbeler, and I'm going to do this one. It's got a sort of a clever scheme to it. I'll give it away. The idea here is that if we can find a point that's not on the body about which to take the some of the moments, we can find the missing thing by removing some of the forces. Like, so the force that's coming through here, because we're take the some moments about this point. It's kind of a neat thing. So anyway, first off, though, in any of these, we need to get the finish your thought. Yeah, we need to get the reactions. Right, so. I guess it's like, maybe something like that, and then like that. There you go. I think that's a little bit more accurate. There you go. Like that, and then like that. Yeah. Okay. And here's the force there of 5 kilonewtons. And here's a force down of 3 kilonewtons. And we have a reaction here that we'll call REY. And we have a reaction upwards here. And then we could also, technically would have one right there, but he's probably going to be equal to 0. And in terms of distances, this is 4 meters, 4 meters, 8 meters. Okay. Some of the moments about A. Because I'm going to do everything over here. I'm not going to even bother finding A. I'm just going to do it right here. So, onto that side. So we take 5, multiply it by 8, and then we'll, okay, so that's 8 right there, and it's clockwise, right, because it's going about A that way. And then this one is also clockwise, and it's going to be 3 times 12. And then this one is counterclockwise, and that's the one we're looking for. And then that's going to be 16, right? Yeah, 16. Equal to 0, and REY is equal to 4.750 kilonewtons upwards. So, like, as I gave away, the geometry of this thing is such that we try to find a point like right there, and so let's see if I probably screwed that up, didn't I? Yeah, I think I made that a little too steep, because I think it's basically a 45, right? Because it's 4 by 4, so it needs to look like a little closer to a 45 right in there. Stuck there. Okay. So this right here is point E right here. They decided to call this O. This is you have a force coming downwards right there, and let's see what that's going to be the 3 kilonewtons. And right up here, so what we've done, they've even ghosted in here, like we draw this in there. I think we're going to draw this right in there, but this isn't exactly accurate right there of where they're showing this. We're actually kind of like carving it right in there. You'll see here in a second. So we want to come down at like a 45. It's going to come like right in there. Right. So this force right here, we're fortunate it's going right through O, right? And so that would be the force at CD, right? CD, FCD. And we see that this right here in line right there is going to be FG, FFG. So it's going to be FFG, right? So we've cut that one, so we've exposed this force right here. This force right in here, right? And so I'll even erase that a little bit right there. We can, let's assume it's in tension. So that would be continuing downwards right here. But so that's a downward component and a horizontal component right there, right? And I think I've established that that is going to be a 45, and that's a 45 right here. So this right here, from how we've named this thing, let's see, I guess this is C. So this was what would this, that was his F right here. So this is F, CF, and keeping this thing, like I say, there's the actual thing. So here's the component, FCF times the sine of 45. Not that it matters when it's a 45-degree angle. And then this guy right here, he's the FCF cosine of 45. Right? And distances, this thing right here is going to be, because we're taking it like right there, okay? We could also, by the way, and do I need to put that in there? I don't think I do. Yeah, pretty sure I don't need to put in the force that's coming vertically right in there. I don't think I have to put that 5 kilo, because we're kind of like taking it into right here. So it's like what? Yeah. So we are cutting it right there. Okay. Where else? I think I also need to put in this reaction, so I drew that E in the wrong spot. Right there. So I found that was 4.75 kilonewtons. Label that as E. This distance right here is 4. This distance is 4. We don't know this distance, but we are able to project out, and we know that well, let's see. What I did is I went alpha. I think you could have just observed to figure out what that angle is going to be. But that angle is going to match this angle right here, right? And that angle should be a rise of 2 and a run of 4, right? So that is the tangent of rise over run of 2 over 4. And I get 26.57 degrees, right? So if I want to find this x right here, I could find this distance, and I could find this total distance and subtract out 4, right? Now I know there must be an easier way to do this, but this is the way that I approach the thing when looking at it. So I'm going to say that x is going to be that rise 4 divided by the tangent of that thing we just looked at, 26.57, which is a little ridiculous. I just took anyway, and then subtract out 4, right? So what I've done here is I found out this total length, and then I subtract out 4, and what we end up finding is that it equals 4, right? It's I swear there must be like some kind of simpler way to be looking at that and decide that that must be 4. So that's 4, 4, 4. Anyway, but it doesn't end up being 4. So if we took out the sum of the moments about O right here, and we look at this and say that's going to be FCF times the sine of 45, right? So we only want that vertical component. It's going to be times 12, right? 4, 4, and of course 4. That's a terrible 4, by the way. So that's going to be times 12. And then this guy, and it's positive because it's going counterclockwise right here, as drawn. And then this one right here is going to be counterclockwise 2, 3, and then it's going to be times 8. And now this one's going clockwise, so it's negative 4.75 times 4 equal to 0. What we're going to find is FCF is going to be a negative 0.5893 kilonewtons. Therefore, FCF is, might as well go back to just newtons, 589 newtons in compression. So that's the trick right there in this particular problem. I don't think it gets used all that often, but it might come up. I don't know. I haven't selected the homework problem, so maybe it would be cruel to like select one that had this in it, but I do not know. Ta-da. It's gonna be a real shock when I get a haircut. And I'm gonna shave too. You just wait and see. Look how he cleans up.